Sir, good evening. Shall we start, sir?
Yes, sir, we may start, sir.
Yes, sir. A very good evening to one and all present here, respected dignitaries, esteemed resource persons, faculty members, and dear participants. It's my great pleasure to warmly welcome you all to Day 5 of the 6 days online faculty development program on emerging trends in IoT, organized by the departments of Electrical and Electronic Engineering, Electronics and Communication Engineering, and Mechanical Engineering of Sriram Engineering College. Let us now proceed to session 1. So today's topic is hands-on session using Gen AI to analyze IoT sensor data. It gives me great pleasure to introduce our distinguished resource person, Mr. N. Murugan and Lieutenant S. Samraj. Mr. N. Murugan serves as an assistant professor at Arjun College of Technology, Coimbatore. With over 14 years of teaching experience in electronics and communication engineering, he has contributed 8 research papers to international journals and conferences. He is actively engaged in research and mentoring students. Followingly, Lieutenant S. Samraj is an assistant professor at Arjun College of Technology with more than 14 years of teaching experience in the same field. He is currently pursuing his PhD at Anna University, Chennai. His research interests include IoT and embedded systems, and he has published 10 research papers in reputed journals and conferences. I now invite our esteemed research person to take over the session. We are honored to have it with us today, and I request you to begin the session.
Good evening, sir. Thanks for the welcome.
Thank you, sir.
And hope my audio is clear enough, sir.
Yes, sir.
Okay, so not wasting our time, we will move on to the session. Today we are going to discuss about how generative AI can be used to analyze sensors, IoT sensors data. Okay, for the first stage, you are actively participating and learning from the faculty development program organized by the Sriram Engineering College, and I'm very happy and great for them for welcoming and giving me an opportunity to share my insights in the field. Okay, so thank you. Uh, why we are going to this topic, generative AI? Okay, so when we are considering about the situation of engineering technology now, we have seen a very great rapid growth in the field of AI, which is artificial intelligence technology. So every department, core engineering department, have started to utilize the artificial intelligence technology to produce their own contents. It's not about just electronics. It's not about just computer science. It's not about any other coding related engineering department, but also the core engineering departments, civil engineering technology started to use artificial intelligence to design the structures, architectures, analyze architectures. Likewise, the mechanical engineering department started to use analyze the products and the design methodologies related to the mechanical engineering. Likewise, everywhere artificial intelligence has been found a great place. And in the field of artificial intelligence, another domain is there, which is generative AI, which is more popular now. So now mostly everyone started to use chat GPT and other AI tools, which can create contents. So that's why we have chosen how these creative generative AI tools can be used in IoT technologies. Okay, so we need hardware and software everywhere. It's not just software engineering which can do a software execution, but every execution has to be done on hardware. So the final product in every engineering department, it's a co-product of software and engineering. So we need it. So likewise, Industry 4.0 currently demands engineers from all domains who are well prepared to handle data and their core profession. And in addition to that, generative AI has become dominant in data analysis. And when it is about having a great big data to analyze, the human power is not capable to do in a very short period. So generative AI can do it in a very short time. So generative AI technology is replacing a very fast computing and analytic tool. Okay, so that's why we choose generative AI. Okay, what is the challenge? Okay, now you have already learned about IoT, Internet of Things, and how hardware is getting connected, how data is transferred from one layer to layers and layers of IoT and architecture of IoT, few cloud platforms related to IoT. You might have already seen in the previous sessions. Okay, so the fundamental problems in the IoT is about data generated by IoT devices. So we started to increase the IoT devices. It's about lakhs, crores in everywhere, and for every time, if let's look at very small numbers, well, let's consider a simple temperature sensor we have installed in a particular room. Okay, if we consider that for every second it is going to generate one data per second, it is going to generate approximately 86,000 data per day. Okay, let's consider a room, a classroom or some other thing. If we have a minimum 10 sensors, let it be a temperature, humidity, and other sensors too. If it generates the total data, it will be about 8 lakhs around. And if it is about monthly data, it will be 25 million data points. It's not single one data. Okay, for single sensor, we have 86,000 data. For a human understanding, it is not easy to analyze those data. Okay, so this is where the problem comes in the IoT. IoT generates a heavy data, it's big data, and there are correlations and there are relativity, but it cannot be analyzed by the human knowledge. So we need some other tools, analysis tools, to do the task. So that's why we go for the generative AI. So now we have that sensors and data are everywhere, and we have every equipment, and even in our homes we have some smart technologies. We talk to the TV and it gives some outputs. Likewise, everywhere generative AI has come. And hardware part, designing a hardware part is not a big task. We have sensors, we can just connect into hardware and we can write a program and we can get data. But the problem is we have a number of sensors, it generates data That's where we stop there. Okay, we are not able to analyze that one. So there comes the analysis gaps. And because of the gap analysis we phase, we stop at the place where we can get the insight. Okay, so that's where the problem comes. So, using this generative AI, we can come into. So now let's have a small intro. It is a generative AI. Mostly everyone will know about it. So for AI systems that can generate any contents, it may be a text, it may be a voice, it may be a code, it may be analysis reports. Okay, based on the given data, based on the training data which is running behind it. So that systems can be called as AI systems. Okay, and generative AI comes. Example for generative AI comes up. We all familiar with ChatGPT and Google Gemini, GitHub Copilot, and Microsoft Copilot and DeepSeek, and there are likewise any n number of AI tools are available to generate different contents. Okay, okay. So what is the best part here? Okay, when we start coding in an embedded system and IoT systems, we have to start from the scratch using from we have to start writing the code, and we have to debug every errors, and then we need a statistics knowledge to analyze the code. These are the great problems when we follow the conventional approaches. Okay, what if we use a Gen AI power approach? So we can use any chat GPT like tools to write the code, and we can also use the AI tools to debug the results, debug the codes, and analyze the results from the hardware setup. This is how we are able to analyze all data and in a very simple time and very fast manner. Okay, so the new workflow because of the generative AI has moved a different bit. Okay, we have sensors produces data, and the data is given to a AI tool. We are giving prompt to the AI tool to analyze the data. So AI tools give the code, and we get the insights. It may be a chart, it may be some understanding format, it may be a text, it may be image, and but it correlates all data, and it analyzes all anomalies in existing in the code, and it provides the data. So this is a very helpful in the sense. Okay, okay, at the end of the session, so we are planning to implement a complete IoT data pipeline from sensor to final analysis. And also, we want to apply some generative AI tools. Most preferably, I'll be using a ChatGPT and Gemini, which is available everywhere. You also can practice at yourselves. So that's why I have chosen that one. At a very small level, we are going to just use the temperature and humidity sensors and writing a code, and then we'll be moving about the how to get analysis reports from the projects. Okay, so this is where it is expected that we can have a very good experience at the end, and we will be able to learn how we can use AI at the level of analysis, at the level of debugging, at the level of coding, and at the level of the final research. Okay, so this is the plan of the session. Okay, and now we will move into the next. Okay, before beginning into IoT, so there is a great plan of the project. Okay, so if I am going to implement a smart home or smart temperature based fan in my home, or smart activity which is related to my home, I'll be choosing the computational capacity of the particular microcontroller. I'll be dictating how many sensors I'm going to use. Likewise, there are criterias based on which I am going to choose the right hardware. So here I have just listed a few hardwares, which is very simple. Okay, ESP32 and Raspberry Pi Pico and Raspberry Pi 4. When we compare about cost and language, which platform it is suitable, it differs everywhere. There will be a difference. Okay, so for a simple analysis, for a smart home application, ESP32 works better, and Raspberry Pi also is okay, suits well. And we don't need to go for a Raspberry Pi 4 for a smart home automation like lighting, smart lighting, or smart control in our homes. Okay, because it offers us high computation. It's like a mini computer, but cost wise it is somewhat bigger. Okay, so when we need to use some high level image computing, then at the sense we can avoid ESP32 Raspberry Pi Pico, and we will be preferring Raspberry Pi 4. Okay, as of now we will just consider ESP32. Okay, so ESP32, we know that one, it has a dual core processor, and which can run in the speed of 240 megahertz speed. And when we look into the memory, it is having a very low memory, 4 megabit flash memory only, which is used to store the code. Okay, so it has some limitations. But The benefit of ESP32 is about it has internal inbuilt Wi-Fi connectivity and inbuilt Bluetooth compatibility, and it accepts 34 inputs, and it works with a very low voltage, which is 3.3 voltage, available in every digital systems. And as it is a very smaller device which has low in budget, it is mostly preferred in very small IoT applications. Okay, and likewise, if you consider a Raspberry Pi Pico, which is also having a very small memory, 2 megabyte flash memory, but it has ARM Cortex processor, and the speed compared to ESP32 it is lesser, but it has additional functionality which is it can support Python, the another programming language. So ESP32 supports C, C plus language. Raspberry Pi can support additionally Python language also. So when we discuss about a Python language, Python supports many libraries. Instead of writing every line of coding for a particular function, we can just refer the libraries available in the Python to do any task. That is the advantages of Python. That Python coding is supported in Raspberry Pi. Okay, it is about the programmer who wants to choose whether ESP32 or Raspberry Pi Go based on the need. And now for a simple project, I am gonna choose DHT22, which is temperature come humidity sensor. It can sense temperature and humidity also. So, which senses the temperature in the range of minus 40 degrees Celsius to 80 degrees Celsius, and which is mostly used in the student project, and which is available and reliable in most of the temperature ranges. Okay, and it provides a single serial line of communication through which we can just get the data directly by reading it. Whence humidity and temperature are read through a serial data. We don't need to use two terminals to read those two data separately. Okay. And for these sessions today, we are going to use these software tools for hardware programming. Mostly now we are going to use Arduino IDE, and for a ESP32 programming or any Arduino IDE program, we will be using Arduino IDE. Okay, so as it is a very open platform, it is available everywhere. I have also preferred that one because the content of the FDP today, what we are learning is about not about programming. It's about how we can use generative AI to code and debug. Okay, so I have just used Arduino IDE. Another platform is Tani IDE, which is suitable for a Python programming. If you are willing to do some Python programming and we are going to implement the program in the Raspberry Pi hardware, then Tani IDE has to be chosen. Okay, so and now we have written a code and the hardware programming purpose that tool we'll be using. For the data analysis tool, I am preferring to use Google Sheets. Okay, Google Sheets and Google Colab, and this is mostly so much important because Google Sheets are open and very web-based sheets which can record any form of data. Even images can be converted into some other blob format and can be stored in a Google Sheet. Likewise, Google has about 15 to 17 GB of data available, which can be accessed from any device. It provides a cloud-based access. So, if you are having an IoT devices at different places, and then it can be used to store your data, different places data to a single Google Sheet from which you can perform any analysis. And Google Colab is a very great platform, open platform, which runs on Python, C, C program, anything. Okay, but mostly it is used to run Python codes, which is also a web-based platform. You don't need to install any softwares. You can just to open the Google link and through which you can directly run. Whatever for the interface through the Google Colab interface, we will be writing the code, but the execution will be happening in the Google server CPU. So the computational capacity of the Google Colab is very big. Okay, so for a simple system, general purpose PC, general purpose mobile, what we currently have at our hands, sometimes it may not be suitable to run very big codes. In that scenario, Google Colab will be helpful. Okay, so we can connect any devices, we can collect any data from the device sensors, and it can be stored in the Google Sheets. And from the Google Sheet, we can run an analysis which can be done by Google Colab. Okay, and Pandas and Matplotlib libraries generally and accessories and its internal libraries available with Python libraries, and which is also already pre-installed in Colab. Okay, And the next level analysis, how we are going to use AI technology in these two levels. We are going to use ChatGPT and Google Gemini. So these two tools are familiar already. We are started to use ChatGPT for several many purposes, and today we are going to discuss about how coding analysis can be done through ChatGPT. So in addition to this, Google Gemini also we are going to discuss. Okay, why Google Colab is needed, and why Google Colab we are choosing here, we are gonna discuss about. So it is a Jupyter notebook. Everyone, I think, familiar with Jupyter notebook. I think so. It is a platform which can run Python programs. Okay, so you don't need, generally Jupyter notebook has to be installed on your computer. In the sense of Google Colab, it doesn't require any installation on your mobile phone or any devices, but it can be just open through a link. Okay, and it runs on the Google server, so it doesn't need any computational power from your phone or any devices you are working with. But as it is running on the Google server, it can extend to any computational power based on the plan you have subscribed. Okay, and it, as it is in the Google cloud, and it can already have any libraries, Python libraries installed in it. You can just directly refer. If you are running any Python libraries, if you want to run any Python libraries in a particular hardware, Raspberry Pi 4 or 3 or any hardware, initial step was to first upload the libraries in your Python library, then you can use it. But that problem is not there in the Google Colab. So, and as it is cloud, you can share it to anyone and you can view them. The next level, Arduino IDE, mostly everyone will know that one, I think. Arduino IDE is an open source platform where through which you can run any embedded system program written in C, C++ to several different types of boards. Okay, Arduino IDE supports general Arduino developed boards and also a ESP and different boards. For any boards which is not supported by Arduino IDE, you can also extend install board managers to add that board also. As it can be customized to your need also. And then it has several libraries, any boards you can install. Likewise, it supports several libraries. E- every sensor is developed by different companies, and every sensor will have a different pattern of data, and it will have a different pattern of communication also. So these communication protocols and communication methodologies does not match with the hardware programming. We may not understand the data very well, so there might be a great problem with understanding data. We may sometimes take a different data. Okay, so that in that case, we are required to install a particular library for the particular sensor, which is also can be very easily done in Arduino IDE. Okay, so when we are going for the exact execution, we will see the steps again. Okay, and then finally the chat gpt. The chat gpt can be used as a coding partner here. Why ChatGPT is preferred here? Because it is a very large language model given by the OpenAI company. Okay, and compared to different AI tools, ChatGPT from the reviews, literature reviews, ChatGPT is preferred as a second choice for coding. Okay, and this, as it is about a large language model, it provides a very well coding with minimum errors. Okay, and let's see about how to use the ChatGPT for IoT. You can see a few examples for a code generation. We can just give a proper prompt to the ChatGPT and it can generate any code. Okay, so for example, for a code generation, let's consider I am going to interface the temperature and humidity sensor DHT22 to the Arduino board or ESP32 board, okay, which has to sense the data for every 10 seconds, and then let it the if I'm giving the prompt for that one, the code will be like this: write Arduino code to read DHT22 every 10 seconds. Likewise, a very simple code, right? Okay, likewise, if I want to have an explanation in the code, you are already having some code, but you don't understand the code, then you can just copy the code into the chat gpt, and you can give the prompt that explain this code, and then it can explain the code line by line. Okay, and likewise, if you are already having a code but you are getting errors many times, in that case also you can give the code and give the error reports to the chat gpt, and it can analyze, it can debug the problem and why the problem is happening. Then it can give you directions to correct those errors. Okay, and finally, and additional to this one, writing code and writing correction to the code and fixing errors in the code. And after you are getting the results from the code, okay, you are getting data from the sensors. Now if you want to analyze the data, then you can directly analyze from the chat GPT. So for that also, like this prompt, calculate statistics from this temperature data. So if you are giving the temperature data, chat GPT supports file uploading. Okay, you can copy data with some limited contents. You can just copy the data into the prompt space, and it you can just give the command calculate statistics. It can read your statistics. The sensors data and it can analyze and can give you a reply. Okay, so this is how ChatGPT can be used. And then the next Google Gemini. And ChatGPT and Google Gemini are two different AI tools, generative AI tools, which made by two different companies. We know that one. ChatGPT was made by OpenAI company. Gemini was made by Google company. Okay, so what is the benefit of Google Gemini? Okay, when we have two different AI tools, likewise there are many more AI generative AI tools these there. Okay, why? What is the best of Google Gemini over this one? Because it is a Google product. Okay, so as I was already telling that we are going to store data in Google data sheets. Oh, in that case, Google is the same company which has this Google Gemini, and we are going to write. Google also offers Google Colab, the engine which can run programs. So if we are having a code written in the same platform, we have stored data in the Google Sheets, and the inference time gets very reduced. The servers, the interaction between two different entities gets reduced, and likewise the support behaviors. And as it is all from a single company, it can support a very well structured. It may have a very fast response. And with the Google, currently it is offered with a very free account. Okay. Direct analysis and direct integration with Google Colab, with Google Gemini is directly possible now. Okay, so you don't need to specifically go for a Google Gemini site and to use the data sheets. In the Google Colab sheet itself, Google Colab working platform itself, you can use Gemini. It is integrated into the same labs. Likewise, Google Sheets also is started to use in beta versions and very familiar we will have that. Okay, so for analysis purpose, how we can use Google Gemini, the example prompts have been given. Okay, so giving a prompt is very much important. How we are defining the data, defining the prompt, and how it is going to respond. The proper prompting is very much important when getting the proper result from the AI tools. Okay, if it is very ambiguous, if it is not well defined, then it may take any data as assumed, and you may get some assumed data as output. Okay, so it is going to just search over a very n number of platforms and compass data, then it going to analyze and gives you data. So our prompt has to be a very well structured and very well defined, and it does not lead to any ambiguity. Okay, so see here example prompts. Okay, it is all samples only. Okay, it is not the perfect prompts anyway. Okay, I have temperature data in my Google Sheets, analyze it for patterns, generate Python code to load this CSV and create a scatter plot. Okay, so this doesn't mean the Google Sheet, which Google Sheet I'm using. I may have n number of Google Sheets. Okay, so it is also ambiguous. Okay, but in that case, it can analyze and it can give you back replay so that you can directly upload Google Sheets also. Okay, it supports. Okay, but it is just an example for prompting. Okay, so when we compare ChatGPT versus Gemini, which one we can use? And as you can see the tables here comparatively, cost wise, Gemini is currently free. Okay, and Gemini is currently free and it is integrated with Colab, and ChatGPT was initially free. Now some pro versions and file handling versions have limits about 3 or 4 uploads or file generation up to 3 files per day, I think. And as I was working, 3 files per day can be generated from ChatGPT. Beyond that, we cannot generate, and we have to wait for 1 day if it is a free free per plan. Otherwise, for a premier versions and next level versions, we have different possibilities also. And the code quality, when we compare about ChatGPT, and both are very nice, excellent. And integration, ChatGPT is a single tool for any analysis or debugging or any other next level Google Sheets. We have to use some other third party, another platform, data sheets or data platforms. But in Gemini, Google Workspace is available. From the Google Workspace, you can integrate any VATs, Google VATs, Google Sheets, and Google Colab, then Google Gemini. So the integration of all tools together in a single document is available through Google Gemini. Internet access, mostly chat GPT has a limitation, and you cannot upload a very fast data and very high big data, which has a limitation. Gemini currently is free. Okay, we cannot come to a final decision that the Google Gemini also will be always free. Okay, so it's about the market scenario and the context length and how many tokens, how many contents it can be taken. So it is also when compare Gemini looks good. Okay, so for the most used one is generally a chat GPT. Okay, so but anyway, it both supports most of the functions what we are going to learn today. Okay, and the recommended tools are here. Okay, so anyway, we will touch both together today, and as it is enough, and then it is not about just having a hardware and we are generating data and we are just analyzing through some other AI tool. There is a heavy need that these data has to be stored in a cloud data platforms. We know that one already. And when you study about the IoT architecture also, you might have already seen that the IoT architectures, the edge level, fog level, and the final cloud levels. Okay, so most of the data are the IoT data are required to be stored in a cloud servers, and every levels are there. About 6 levels of implementations are there in IoTs. And for a simple level without cloud access and up to the final level, sixth level, fully cloud access. Okay, computation, manipulation, debugging, and analysis, everything is going to happen in the cloud platform. Okay, as it is a very big device which generates a very big data and big network, cloud platform is the only option for storage of IoT data, unless it is a very small application we are testing at homes. Okay, so generally now for this session also we are going to use for a simple demo we are going to use about a Blink IoT cloud um, service, and there are some other ThinkSpeak is there, IFB is there, even MATLAB related ThinkSpeak is available there. So every platform, as we are comparing ChatGPT and Google Gemini and other Gen AI tools, likewise Blink and ThinkSpeak and other devices have different parameters to take and give it away. Okay, so for the mobile dashboards and controls, Blink is better, but it has a limited access that it can handle only 50 queries in a month. If you are making any query to the dashboard, it has a limitation when it is a free plan. Likewise, whether it is AI assistant possibility is there in Blink, it says it is yes. Okay, in the Blink platform, Blink is a cloud IoT platform which is used to store IoT data and which gives a analytics of the IoT data. Okay, we will touch once again back. Okay, so this creation of this dashboard analytics also can be done through the AI assistant, which is integrated in the Blink, but it is not available in the ThinkSpeak. ThinkSpeak is another sub company platform which is given by the MATLAB company. And as we know that one, MATLAB is a very greatest computational tool for engineering. It supports fuzzy logic and it supports neural network and artificial neural networks. Heavy, high computation possibilities available in ThinkSpeak, but at the free level, and we are lagging there also. Okay, so, and if you want to have a interactive control apps, for example, you want to write a program and you have to control your home appliances automatically based on the temperature, based on the people's availability, then for that purpose Blink is good enough. Okay, so if it is a application where data is heavy and it is generated a very big data, then Blink may not be suitable, but ThinkSpeak will be suitable, as the MATLAB libraries are suitable to data analysis integrated together. Okay, Okay, so Blink AI assistant, how Blink AI assistants can be used. So Blink is a console website. Let me hope I have already opened it. A moment, please wait. I'm just taking the window so that you all can see there. Yeah, hope everyone is able to see the screen what I'm currently sharing now. Okay, this is a Blink dashboard. Okay, currently which has reading continuous reading shared from devices connected to internet. A single sensor which is DHT22 for our current projects, which continuously records the data temperature and humidity of a particular room close to me, okay, and continuously sending there. You can see the chart and see here, okay. So if you compare here, this is a dashboard app. For this app, a dashboard app, if you see the left side contents, you can find out there are how to create a dashboard and developer shows devices and everything has to be done through a manual process, and also it can be done through a AI assistant. Okay, so that's what a Blink AI is treated to be a best platform for a many application. Okay, so you can see here the continuous temperature data from a single point is shown here. It looks to be very constant here, okay, but the humidity level have seen some ups and down, slow variations. Okay, this is all the data points for a single hour we are getting in the Blink console, which is a cloud platform, free cloud platform, accessible everywhere. In addition to the this analysis and charts, Blink console for a premier version supports AI integrated analysis also. So for small AI, Gen AI integrated applications, we may prefer Blink console. Okay. Now again I'm moving back to the slides. Okay. Okay, for the hands-on session now, so this is a very simple project I have chosen. Okay, today's project we are going to just monitor a classroom for a temperature and humidity. Okay, okay. So the scenario is about continuously we have to record the humidity and sensor values, and from this we have to get some analysis. Okay, that's what the task. Okay, how we can do, so we have a classroom, and we have a sensors kept in the classroom, and this sensor is connected to the ESP32 microcontroller, which has the internal internet connectivity and Bluetooth connectivity also through serial monitor, and it produces the data to a computer. For this demo purpose, I have taken data from a serial monitor and I'm just manually copying into Google Sheets. Even directly copying the data can be directly sent to from ESP32 Google Sheet is also possible. For a simple demo, I have chosen serial monitor. From serial monitor, I will be manually copying to Google Sheets. From Google Sheets, we will be running AI analysis methodologies. Okay, okay. Let's see further. Let's ask AI to write our first program. Okay, so this is the left side, this is the prompt. Okay, hope you all can see the prompt. Okay, so this is the greatest prompt suggested by another AI. Okay, it is not the direct prompt. Sometimes when we use the chat GPT, we are already started to use Gen AI tools, and we start to give a very short commands. But AI to have a very effective output, The prompt has to be very well defined. Okay. Can you see here the prompt act as an expert Arduino programmer? So this is the role of the particular Gen AI we have to first assign. Okay, so this is the scenario. Most of the time, we just give the data, just create a code. It can it can consider the AI tool can consider itself like any person. Okay, it can consider any level of computational capacity. If we don't define it very well, it may choose some other options. Okay, let's see here. Act as an expert Arduino programmer. Write code for an ESP32 microcontroller. So through which I have just defined which controller it is going to write the code. Okay, and again I have specifically mentioned that you have to read data from a DHT22 sensor, temperature and humidities. So it doesn't stop there. Okay, again we are just clarifying the same operation. Okay, for the programming purpose you can include all necessary libraries. Okay, so this DHT22 sensor is going to be connected to the pin number of 15. Okay, so we were seeing that ESP32 have 36 34 IO pins. Okay, we can use any pins, but here for a writing program, we have to define them. Otherwise, it will take automatically some pin numbers. Okay, for a hardware connection, you have already planned to use a 15 pin, then you have to define in the prompt itself. Okay, and you can see here temperature can be taken in Celsius form and Fahrenheit also. Okay, so it has been mentioned here Celsius and humidity. Humidity has simple values. I want these values to be printed in a serial monitor. Generally, serial monitor will be continuously sending data. If unless specified, it may use CSV format also. And I need them in CSV format. I have specifically mentioned CSV format. Now, I want the data to be read in every 10 seconds, and it has to follow some error handling process. Otherwise, first, generally all AI servers, Gen AI servers will take your prompt. It will automatically generate codes in a short moment, and it will copy the code from the server to you. This will take some time. Okay, and if you are just not including the error handling process, it will just take the code which is generated in the AI server without debugging the code, and it will send it to you. If you are giving a command to error handle, it can analyze the code itself, and it can provide some error handling purpose also. Okay, and it can include commands if necessary, and the final line is provide the complete ready to upload code, which gives the greatest explanation that it has to be ready to upload. There should be no correction further. Okay, so let's see this how it is going to work with ChatGPT. Okay, for the demo purpose. Okay, now I will be opening the ChatGPT. Hope everyone can open and try ChatGPT. Okay, I'll be copying. Okay, so I'm sharing my ChatGPT screen now. Okay, even in your mobile phone, if you have an app, you can try there. Okay, and it is not a very complex task. If you don't have ChatGPT app in your phone, you can just install there. Okay, and by going to Play Store, if you are searching for ChatGPT, it will be available there. And if you want to open in web, you can just use ChatGPT search in Google, type ChatGPT, and it will provide you the ChatGPT.com link. Okay, and now I'm going to give the prompt here. The prompt what I have mentioned in the. Okay, let's see how it is going to generate a code. So the Arduino code is available. Hope everyone can see the code. Okay, so the additional feature of AI is about it supports direct copy code. Okay, so here you can see that this is available in AI tools. Okay, if you are having any other tools, you have to manually copy if the codes or any other content you require. But this Gen AI tools, most of the Gen AI tools started supporting this feature. Okay, by clicking this copy code button, this the entire code will be available. Okay, okay, how we are going to execute this one? Okay, so now the code is ready. Okay, if everyone is familiar with embedded systems, and hope Arduino IDE also you will be know better. But anyway, for simplicity, now I will be directly going for Arduino IDE. For that purpose, I will be sharing on another screen. Okay. Okay, so now Arduino IDE screen is available, right? Okay, so Arduino IDE is a platform which can be installed in mobile phone also. Okay, so for people who are having mobile phone, you cannot currently do it, but anyway, in some other time, if you are interested to do something further, you can do it there. Okay, Arduino IDE is supported for Android phones also. In even for embedded systems and any other capstone project purposes, we are using already Arduino IDE. It is very simple to use. Okay, and now I have installed an Arduino IDE. When you are opening it up, it shows the structure like this. Okay, the first part, programming part, I don't want to touch here, but anyway, for a simplicity, the setup function, it includes how the code, how the pin has to be configured, like that. Initial setups which will be running one time has to be done here, and the program which has to be run repeatedly run, which is the main part of the program, has to be copied here. Okay, so for the purpose of coding, we will be going for file, new sketch. Okay, so by clicking the new sketch, you will be having this screen. Okay, this is a screen you will be getting when you are clicking new sketch. Okay, and then the important things about choosing a board. Okay, I think full interface is not visible. For simplicity, I will do something else. Okay. Hope now it will be visible, right? Okay, so for a implementation of the project at the hardware level, we will be writing code in Arduino. Okay, so we are using GenAI to write the code, but it has to be done in the editor which is available in the Arduino IDE. Okay, file, new sketch. Through file and new sketch, we are getting to this page. We have to choose the board, which board we are going to use. Okay, so currently I'm going to run some ESP32 boards. Okay, you can see here it is listing two main boards. Okay, and for a new installed Arduino IDE, you may not see this ESP32, for which you have to install ESP32 boards. Okay, and it is also very easy one. By if you are going to boards manager, you can just search ESP32. You can find out some libraries. Okay, so when installing ESP32, you have to choose ESP32 by Expressive Systems, because the most of the ESP32 boards were developed by this company. So if you want to do program for the particular ESP32, you have to choose this one. I have already done installation. Otherwise, this install the button will appear like install. Okay, this has been already installed. In case if you have to do, and if you are willing to do, you can choose this one. Okay, and now I have chosen the board, and then I have to choose the proper port. Okay, so this is a COM6 port. I have already connected this kit, so I will be directly connecting. For this also, you have to go into the computer menu, start device manager. In the device manager, if you are looking into the ports setting, how many ports are connected, the serial port has to be chosen. Okay, the USB port, serial port, it will be listed, and it is also, you can just by referring in the chat GPT, you can get help. Okay, it is not the big task. I will be just copying the code what we have got from this chat GPT. For this code, first step is about compiling, verifying the tick mark. Okay, the compilation is happening. You can see here compiling, it shows done compiling. Now the second step is about uploading. Okay, for the uploading purpose, I have to connect the kit. I have already hardware is, kept connected, so I'm just connecting, uploading the code. Okay, for a small problem here, I don't have connecting possibility to pin number 22. So instead of that one, I am choosing a pin number 22. Okay, instead of 52. Okay, I'm compiling again, and after compiling, I have just chosen to upload directly. So upload will happen immediately. So you can see the status here, compiling, or in some other case it will be shown in left side also. Now uploading is happening. Okay, so uploading has completed. Now we have to see the outputs. The Arduino IDE supports serial monitor, which is one another terminal platform for displaying serial content. Okay, serial communication content, which is also available in the tools menu. Tools, serial monitor. Okay, so in the serial monitor, you can see here serial monitor 115200 baud rate, which was written in the program. You can see here serial begin 11. This baud rate has to match. Okay, now we have got a problem with the code, right? Okay, so this is a very greatest problem we are currently facing with Gen AI technologies. It needs improvement. From the direct code, we cannot implement into a particular sensors, okay, which has to be perfectly defined. Okay, for this purpose, okay, so I have already corrected code available with me. Okay, I'll be just copying them. Okay, this is by experience, you will come to know how these programs can be corrected from Gen AI. Okay, there are times here, if I am copying this error to the chat GPT also, it can correct. Okay, so if I am giving error also, it provides some debugging steps so that I can do that one. Okay, for a simplicity purpose, instead of going further with that, I will just take a working code and I will move again. Okay. So this was a idea behind the Gen AI, and it was also the prompt and related to Gen AI, and we cannot directly implement any programs as of now, as the Gen AI tools is getting improved, and the LLM models behind every Gen AI tools is also getting improved. Okay, so initially we had just one single Gen AI models which was running one servers. Currently we have several models, several LLM models, large language models we generally call. Now a few Gen AI tools have started to give the customers option that we can customize language models, large language models. We can choose one or two three language models for a particular specific application, from which it will be giving results. Okay, now I have the code. Okay, I am correcting my code. So this is a very simple code, okay, which is directly getting the result. It was the previous code was calculating something too much. Okay, and let me check again now. Actually, steps of debugging the code is about verifying the code, and then we have to go for it. Okay, here now you can see the serial monitor started to send some signals. Let me clear once for your visibility. This is called garbage value because the bar rate is not matched. So if you go with the program, you can see here serial begin 9600 bar rate, but the monitor has set to receive data with a higher bar rate. So if I don't match this one, I will not be able to read the codes. This is general condition in every serial communication. Now I have set now we can see that for every 10 seconds, for every 2 seconds, the particular temperature is reading the data and sending through serial monitor. These are the data, right? Okay, so this is how the data is being generated in IoT. If I want them in the CSV format, the code has to be in CSV format. Okay, for the next level, we will move on. Okay, continuously we are getting code. Okay, again moving back to the AI generation code. Okay, so AI generates code in the way like this. Okay, okay, which includes some error handling also. So the previous program was giving some error. It was the error command already written inside the code. That is most important. Okay, so that generally when we are writing, we will be considering plan the execute options A and options B. Sometimes we may not consider the scenarios of part C. Okay, so for a proper error handling, part C also has to be considered. That AI generated codes allows that one. Okay, okay, so this is the steps of uploading the code. We will be connecting ESP32 and we will be choosing boards and we will be selecting compots, verifying, uploading it, and then we went to bar rate. Okay, so now we have got some values like this. Okay, so if I am writing the code into generate the CSV format, it will be generating a timestamp. If you see here, the first data, first 2 second data was the timestamp 542 6. Likewise, it will be producing some timestamp data and then the temperature and humidity. So this is called CSV format. For every second, it will be generating this data, and for data, this data will be getting going ahead for every 2 seconds getting updated. We will be receiving this data from a sensor. Okay, then what we can do, the next level is about how to analyze this data. We have to copy this data into a Google Sheet. Okay, so from the Google Sheet we can analyze them. Okay, let's take some data. Okay, so I think we are running out of time. Okay, I'll move a little faster so that at least I can touch Gen AI to analyze the data from Copilot. Okay. Okay, so for creating a Google Sheet, okay, so I have opened Google Drive from which I will be creating a Google Sheet. Okay, this sheet I'm just naming it for understanding purpose, just IoT data. And I have already copied the data. I hope you have already seen it. Okay, I'm just pasting them. Okay, so Google Sheet I have opened new and I have copied the data. I'll be saving them. And we will make a little assignment so that we can see those. Freeze the first row and let it be for okay. Okay, so this is how data can be recorded in a Google Sheets. Okay, and the next level we have to use the Gen AI. I'm gonna directly copy this one into Google Gemini. So as we don't touch the tool, instead of using a chat GPT, I want to touch that one. And with this analysis, we will end up the session. Okay, okay. I have opened the Google Gemini tool. Okay, I'll be just giving. Okay, so I'm just copying the prompt, which is also already I have tested. The main method is about we have to use the AI, Gen AI, to not write the code, but we have to write the code to analyze the code. Okay, so that's what the main task. We have to have a priority using AI. Okay, so the code has been generated by the Google Gemini, and let's see. Actually, this code has been generated. I have to run this code in Google Copilot. So Google Colab is available now. Instead of CSV data, I'm just directly copying the IoT data. Now we are running the program in Google Colab. We have got some errors. Actually, it needs some. So this is how we are going to run the code, and through which we will be getting a report and also the visualization material. So the visualization will be yielding some graphs through which we will be getting some insights from the data, and whether the temperature is how fluctuating, what are the difference, whether there is a inverted representation versus humidity and temperature happens. Likewise, something which we generally don't consider also can be suggested by the AI tool. Actually, I'm getting some error. I want to correct it. For the time being, I will just stop here. This is how we come up to Gen AI tools Colab, and we are producing output for the analysis of IoT data. Okay, so this is all up to analysis of IoT data. Okay, at the final level, we will be having the cyclic patterns related to the codes, and which will be giving some more best insights from the data. Okay. Okay, so with this, I'll just end up the session. If you have any questions related to this, you may ask now. Okay, any questions? Okay, so I think the session was nice, and the second session has to be done by, and I have already taken 5 more minutes from Sir time. Okay, the host members can transfer the session to him. Thanks.
Thank you, sir.
Yes, sir.
On behalf of Sriram Engineering College, I would like to express our heartfelt gratitude to the distinguished resource person for conducting and enlightening hands-on training on using GenAI to analyze IoT sensor data. Your insightful presentation and practical guidance have significantly enhanced knowledge and understanding of this topic. We sincerely appreciate your valuable time and effort. Thank you, sir.
Thank you, sir.
Let us now move on to session 2 of day 5, and today's topic is behavioral IoT. I'm honored to present our respected resource person for today's session, Dr. S. Krishna Kumar. Dr. S. Krishna Kumar is a distinguished academician with over 23 years of teaching, research, and administrative experience in the field of electrical and electronic engineering. He is currently serving as a professor and head of the department. He holds a PhD in power electronics from Anna University, and his areas of expertise include power electronics, electric vehicles, renewable energy systems, and smart grid technologies. He is a recognized PhD supervisor under Anna University. His research contributions include 20 publications in reputed journals and IEEE conferences, reflecting his strong academic and research orientation. Sir, I now hand over the session to you.
Hello. Am I audible now?
Yes, sir. Yes, sir.
Yes. Yes. Okay. Okay. Sir, is my screen visible now?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, yes, sir. Thank you.
Yes, sir.
Uh, Sir, today we are going to see about behavioral IoT. My previous speakers, beginning from Monday, have given enough foresights about IoT. So, behavioral IoT, as you can see here, I have given intelligence meets Internet of Things. So, already IoT has developed for more than 7 years. If you give intelligence to IoT, if you give intelligence to IoT, what will happen? That is this behavioral IoT or IOB in short, we call as Internet of Behavior. So you can see this. There are three components of IOB: prediction, pattern, intelligence. So let us go to the section. So my previous speakers, all of them have explained enough about what is an IoT, how it is connected. So how IoT was emerged, connecting people to the physical world. This is how IoT was emerged. Let us see what is Internet of Behavior. Before that, I want to show you some of the global statistics. So as of now, by 2025, there are 75 billion devices connected. That is hardly 9.5 sensors per human being. That much sensors are already now connected. Okay, the total business value of Internet of Behavior is 1.1 trillion, and the data generated every year is 4.8 zettabytes. So we can see the volume of data generated. Okay. So every year, the number of sensors connecting is gradually increasing and rising. As you can see in the chart, it is growing rapidly, increasing from year to year. And this pie chart shows you how it is increasing, how it is shared between different sectors. So you can see IIoT, increased Internet of Behavior, is gaining significant importance, and more industries started developing Internet of Things as well as Internet of Behavior. So with this data, let us see what is the difference between IoT and IoT. So IoT, as we have seen in the earlier slides, there will be a lot of sensors. All the data collected from the sensor is given to the cloud for analysis. Let us take a simple example. So, you see, in traditional IoT, it is like an alarm clock. Suppose you set in your mobile phone, I want to wake up at 5 a.m. in the morning. When the time reaches 5 a.m., it will give you an alarm. That is, once data is happened, it will give you an indication that it has happened. So it has a static rules, okay, and it is a reactive behavior. Behavior. The behavior is reactive in nature. So limited context. Suppose you want to set the temperature to 35 degrees Celsius. When 35 degrees Celsius is reached, it will give you an indication. Now let us see what is behavioral IoT. Behavioral IoT is pattern learning, pattern learning, pattern learning. So what is this pattern learning? Just now we have seen the example 35 degrees. If the temperature reaches 35 degrees Celsius, you have to give an indication. Let us take one more example. Okay, 35 degrees Celsius is normal during morning. So let us say that 35 degrees Celsius is a normal one. But during night time, 35 degrees Celsius is not normal. But what IoT will do is it will think 35 degrees as normal irrespective of the time. But IoT, it will see the time also pattern. It will see if the temperature in the morning is 35 degrees Celsius and during night the temperature is 35, and give you a predictive forecast. So that is the difference between a traditional IoT and a behavioral IoT. So IoT basically sees the pattern and it predicts or forecasts what is going to happen in the future. Okay, so we have to give some intelligence to IoT. So if you see IoT is a reactive, reactive behavior. It reacts after it happens. But IoT, it gives proactive actions. So that is the difference between traditional IoT and behavioral IoT. So let us see how IoT actually works, or behavioral IoT works. There are 5 layers. So the first layer consists of sensors. So already my previous speakers have given enough explanation about the sensors. So by using sensors, you can connect the data. The second layer, network layer, how you transfer data, that plays a significant role. The third layer, how you process the data. Once the data is processed, how you are going to do the analysis. And finally, what is the front end which you are going to do to the business customer or the end consumer. Let us see one by one now. So sensors, the eyes and ears of behavioral IoT. So I have given you 6 examples here. Environmental. So as my previous speaker also talking about this, he was trying to do coding for temperature and humidity using DHT22 sensor. So environmental, we have various sensors as shown here: motion and position sensor, biometric sensor, acoustic vibration, image and depth, and the chemical. So these sensors form the data collection. That is the first layer for a behavioral IoT. Next, the second layer. This data has to be transferred. So how does you do the transfer? So we have to use different data transfer for different methods. Suppose you are using a wearable IoT, so that we have to use a different protocol for transmission. For example, you can use a MQTT. By using even SMS or WhatsApp messages, we can transfer their data. So HTTP is a standard web protocol. By using it, we can transmit a large data, but it will take some time compared to MQTT. And even if you consider the LoRa WAN is a long range WAN. You can use this WAN for 15, even for 15 kilometers, but the data transfer is very low. So this is the second layer of behavioral IoT. The third layer, this is a very important in behavioral IoT compared to normal IoT. In IoT, what happens is once the data is connected, the data is transferred to the cloud. And, all the processing will be done in cloud. But here, we are not going to transfer all the data to cloud. Rather, what we are going to do is we are going to process the data at the sensor in the pixel. So this is popularly called as edge computing. So you can see how it happens here. So sensor, actuator, controller. So this forms the IoT device layer. After that, you give it to the edge gateway. Okay. So edge gateway, local. So you have to remove the noise from the sensor data, and you can do the PML, and then transfer it to the cloud, and finally store in the cloud. So how the data is processed, that is given here from the chart. So most of the data you can see is done in edge gateway. So the data is not processed in the cloud, rather it is processed in the edge gateway. So this is the third layer of computation in behavioral IoT. After that, the fourth layer, pattern analysis. This is a very important feature of behavioral IoT. So let us see how does it work. So raw data is extracted and feature extraction, and it is given to a tiny ML model. So what is this tiny ML model? So everyone is aware about saying about hey Google, right? If you say hey Google, hi Google, the Google wake up. So it will take 120 microwatt to process the data. So this is what we say as a tiny ML model. Okay. So these are the various models by using which you can analyze the pattern in IoT. So behavioral pattern recognition. So there are various types of patterns which we have to analyze. Say for example, I have given here 6 pattern analysis. Temporal pattern. So for example, you consider traffic. The traffic every week Monday morning at 8 a.m. the traffic will be high. So this is a temporal one. So Monday morning 8 a.m. every week the traffic will be high. This is a temporal pattern. So spatial pattern, it is based on GPS location. For example, if you consider a tea shop near a college or office, that will be always crowded compared to a tea shop located far away from the office. So this is a spatial pattern. So we need to see the geotag of the office also. So next one, contextual pattern. So the contextual pattern here, you can see multivariable behavioral correlation. So what is this multivariable behavioral correlation is? So you can take HVAC, that is humidity, temperature monitoring, everything we can do based on, for example, uh, the temperature. So when it is cool, I want to increase the temperature. When it is too hot, we have to turn on the AC and reduce the temperature. This is how we have to do the contextual pattern. So collective group of pattern. Collect group. This happens in industrial IoT. So during the end of the shift, all the fans in the company will be turned on. So you can expect a vibration from all the fans together at a time. This is called as a collective pattern. So when you turn on the fan also, you can expect vibration during the turning on of the fan. This is also called as a collective pattern. So the anomaly pattern, this is very, very important pattern compared to all the pattern. So you have to analyze the pattern and see if there is any difference. So this can be done by using various statistical tools. Uh, we'll see that by example in the next slides. So anomaly behavior. So you can see the chart pattern here. So you can see the blue line represents a normal baseline, and when there is an anomaly, that is there is a spike at a time t7. So this is an anomaly. How to analyze this anomaly? Let us take an example of a motor. The motor was supposed to take a temperature of say 50 degree to 70 degree, and the motor runs at 50 to 70 degree. All of a sudden, there is a rise in temperature. What IoT do is it will wait for the temperature to rise beyond 80 degree. Once 80 degree crossed up, IoT will give you a signal that there is a problem with the motor, you have to start the motor. But behavioral IoT, what does it do is, based on the mathematical and statistical analysis, it will understand that there is some problem in temperature, there is an unusual behavior in the temperature, and it will give you an indication that there is a problem in the motor and you have to start the motor. This can be done by using the statistical methods. So the statistical methods are given here: Z score, IQR, QSUM, and depth test. Okay. So this is another example. This is based on the vibration of the motor. You have to collect the data from the motor and during different times. So collect the data of vibration which happens in the motor and see that the vibrations are normal. Suppose the vibration increases, the behavioral pattern will analysis and give the analysis and send you data that it will happen in future that there will be a problem with the motor. Okay, so this will be done by using a predictive maintenance trigger. So let us see the example. So before that, let us see how to collect the data and process the data. So first, after the sensor gives you the data, so MQTT broker, already we have seen that how to transfer the data from the sensor to the devices. So by using different tools, first one, ingestion, we can collect the data. After collecting the data, we have to pre-process the data. That is done by deionizing and normalization, right? That is by resampling the data and remove the unwanted noise. And then we have to process the data by using a statistical method which we have seen in the previous slide. And collect all the data and give it to the training models. So based on the behavioral pattern, analyze the data and take action based on the data. So this is the data pipeline, how we do it. So let us say how this happens in terms of behavior. So I would like to introduce this term digital twins in behavioral IoT. So what is this digital twin? Say, let us take an example. If you see your face in the mirror, whatever actions we do here, that we can monitor, see in the mirror. The same thing, if you do for a physical device in digital simulation, this is called as digital twin. So let us take the example of an Airbus. Yesterday, speaker explained about Airbus. So what Airbus do is they will embed more than 272 sensor in the wings of the Airbus, and all the data are connected to a simulated Airbus which is kept in the office of the Airbus. So this data will be collected, analyzed, and it will predict what will happen to the Airbus during different conditions in the simulated environment. So once a problem is going to arise, immediately it will be given information to the team that something is going to happen in the Airbus, and immediately the Airbus has to go for maintenance. So this is called as a digital twin. Whatever we have a physical device, the same device will be simulated in the system, and all the data which we collect will be kept, analyzed, processed, and what will happen in the future will be predicted much in advance so that any anomaly can be prevented. This is one example I given for Airbus. Airbus is doing this for all the flights which they sell. So this is about digital twins. So let us take a few more examples. So the first application which I have taken here is smart home behavioral IoT. So smart home behavior. So let us see what is the difference between IoT and behavioral IoT. So what does IoT do is, say for example, if the time is 9 p.m. in the night, you have an intelligent smart bulb. It will dim the bulb and reduce the lighting lumens to 40% every day. It will understand that at 9 p.m. you will be going to sleep. But what behavioral IoT will do is, it will see that on what day you are at. For example, during weekends on Friday, uh, we may not sleep at night. We may have an extended weekend. We may have a party. We may have watch a TV. So based on the day, it will increase the lumen say to 60 to 70 degrees. So this is the difference between a normal IoT and behavioral IoT. So behavioral IoT will see the pattern. So the person every day, every week on Friday, he will watch a movie or go on party. So he will be having a more light on Fridays rather than on every day. So this is the difference between a IoT and a behavioral IoT. So I have given you many examples. Due to time constraint, let us move on to the next slides. So the same thing which we can do for healthcare applications also. So I have given a case study for this healthcare application in the later slide. Let us see that in the later slide. So industrial behavioral IoT. This example I have given you already. Say for example, you want to take a motor, do the analysis for vibration. So the vibration of the motor is analyzed say for every 1 minute. If the vibration crosses particular level, then IoT will give you a signal that vibration has crossed and you have to stop the motor. But what is your industrial behavioral IoT will do is, it will see the pattern of vibration and it will try to identify the normal and abnormal patterns of the vibration, and it will give you a predictive signal that something is going to happen in the motor and you have to do the maintenance of the motor. So this is how you can do a preventive maintenance of the motor rather than doing the maintenance of the motor after the fault has occurred. So in this way, it helps you to reduce the cost of maintenance of the motor. So this is one application. So many applications are there. Due to time constraint, I'm moving on to the next slides. Smart city. So smart city. So there are many examples for a smart city. Yesterday, speaker was also explaining about smart city. So let me tell you what is happening in Singapore. Uh, as I was telling you about the digital twins in the previous slides. So in Singapore, the traffic data collected from various points is, is sent to the digital twin. In the digital twin, there is a model that it will simulate and send you signal that it will forecast the traffic during later hour, and if for sure there is a traffic congestion, the traffic will be diverted before the traffic problem has occurred. So this is the behavioral IoT compared to the normal. Normal IoT, once you have a problem, it will give you a solution. But behavioral IoT will predict the traffic and give the solution before traffic has occurred. Okay, so this is about smart city behavior IoT. And there are also various applications, agriculture, environmental. So due to time constraint, I am going into this. So security is a very important issue in behavioral IoT. Security is an important behavior. So let us see what it is like having an elephant at your home. So you cannot protect your elephant keeping it in a room, right? So there will be a lot of problems in providing security to the. So what you have to do to protect your data? That is a main thing here. So we have to use a zero trust architecture. Never trust So this is the first thing. Never trust anything. Always verify. Always verify your devices. Authenticate it before using. Put it in use. So network traffic behavior. So you have to see the abnormal pattern. You have to see the analyze the pattern. Based on the pattern, your firewall was to act. Okay. So end-to-end encryption. So we have to do the end-to-end encryption. And finally, the anomaly-based IDS, behavioral intrusion detection learns device communication pattern and flags statistical deviation indicative of compromise. So challenges. What are the challenges in behavioral IoT? Behavioral IoT, if it is leaked, it will create you rather a big problem. Let us see, for example, our employer knows how we work for 1 month. If he knows how we work for a 1 month, will the employer keep us for the next month? So that is a very big problem, right? So the data should not get leaked. The pattern or behavior of a person should be used only for doing the good things. It should not be leaked to any third party person, otherwise we'll be in a problem. Okay. So what are the future trends in IoT? Um, So let us go to this slide. So research direction and doctoral opportunities in behavioral IoT. So there are a lot of opportunities in behavioral IoT. The main thing is edge computing. Edge computing happens at the sensor point itself. So when you process the data near the sensor device rather than at the cloud. So by this way, you can act fast compared to transforming the data to cloud and processing the data. Okay, so I have given the research directions on how to do your PhD. The various I have given you here 8 areas. So this is a simple case study which I have taken for understanding about the behavioral IoT. So let us take a real world example of an hospital. So a patient gets admitted in the hospital, and there is various sensor which is connected to the patients. So first collect all the data from the patient. So after collecting the data from the patient, we are not transforming the data to the cloud. So we are going to do edge processing. What is edge processing? Processing the data at the sensor end itself. So local server will process the data, and we have to detect the anomaly. After detecting the anomaly, you have to give to the tiny ML. So here I said tiny ML. It is a small program which will find out the behavioral pattern of the patient and tell you if there is a problem. And based on that, it will give you predictive data. And finally, it will send to the doctor for approval, and the doctor can give treatment. So this is how a smart hospital can work. Okay. So I have made a hands-on lab session as it was done by the previous speaker. Because of the time constraint, I will skip this. So the key takeaways from my speech is, so the main concept of behavioral IoT is behavioral intelligence. So you have to analyze the pattern. Where if there is a difference of pattern, we have to give indication. That is the basic thing in behavioral intelligence. And ML, machine language is the core. You have to teach by using various algorithms, and based on that, we have to predict the anomaly. And here, edge is not optional. You have to do edge computing only. The data is processed near the sensor and not in the clouds. Okay, so these are the key takeaways from behavioral intelligence. So I have given the suggested book for further reading and online courses from where I have taken my topics. Okay, thank you. Any questions? Any questions? Any questions, sir? Okay, thank you.
Thank you, sir, for the wonderful and insightful session. Thank you once again for all the participants. With this, we have concluded the day 5 of the 6 days online faculty development program on emerging trends in IoT. We look forward to your active participation in tomorrow's session. So the feedback form has been shared in the WhatsApp group, so kindly complete it to record your attendance. We once again express our heartfelt gratitude to the resource persons, organizing team, and all the participants for contributing to the success of today's sessions. Thank you and have a pleasant evening.